Hi guys, I am Chant. Welcome back to my YouTube channel. Today I am going to discuss about quick sort. I think you know what is a sorting technique. In this session we will learn what is a quick sort and how quick sort will work. Come let us start the video. Don't miss the video till end, friends. Implementation of quick sort technique and in a design and analysis of algorithm. In this video, we will discuss about introductions of quicksort and sorting technique. What is sorting technique? Why we use quicksort technique? Comparison of quicksort technique and with other techniques. Implementation of quicksort technique. Come guys, let's get started. Introduction. Sorting refers to arranging the data in a particular format. Sorting algorithm specifies that the way of arranging data in a particular order. Most common order are in the numerical or lexicographic order. The importance of sorting lies in the fact of that searching can be optimized to the very high level if data is sorting in the sorter manner. Sorting is also used to represent data in a more readable format. What is sorting technique? In this diagram, you can understand the unsorted elements are sorted with the arrangement of here is the example BD AC, and this is sorted. After the sorting technique, we have applied some sortings. After that, we got A, B, C, D in the order. As the same guys, we will learn about the sorting technique. In this example also you can see that we have taken random incomes. We have taken random inputs to the sorting technique. In this we are arranging the elements in a ascending order. Ascending order is nothing but the smaller one is the first one and the most higher one is the last element of the sorting. Why we need a quick sort technique? It is used everywhere wherever the suitable sorts is not needed. Quicksort is cache friendly and algorithm, and it is good locality, but it will take some storage capacity. That's all for compared to quicksort. Compared to merge sort, but it is more efficient than other sorts it is working on the divide and concurrent rule, so that it will divides and it will arrange the sortings, so that it is most popular sorting technique. The sorting algorithm is used to inform the information searching, and as a quicksort is faster algorithms, so it is widely used in the better way of searching. It is used to optional searching, optional researching, and event driving simulations. Comparison of quick and other sorts. Quicksort is faster than most other comparison based on sorting algorithm, such as bubble sort, selection sort, and selection sort. We have the worst of worst case, like O of n square. It's nothing but the worst case. Quicksort is also faster than merge sort at the sometimes, which be the worst case of running time in it is given by the worst case of running time is given by O of n into log n, but requires O of n extra space. I have said that before only. It will take some lot of time to access that, and it will occurs the large space of memory. It will occupies the large space of memory. Quicksort is the one of the most efficient sorting algorithm, and this makes of its own must be in the next level. Why we need a quicksort technique? It is used everywhere where a suitable technique is not needed. Quicksort is a cache-friendly algorithm as it has good locality of reference when users are in arrays. It is style recursive, hence all the call optimization can be done. It is an place sort that does not require an extra storage memory in some cases. It is used to operation research and event drives simulations, etc. Comparison of quicksort and other sorts. Quicksort is faster than most other comparison sorts like bubble sort, selection sort, and insertion sort, etc. The worst case of quicksort is O of log n log n, and it requires it will require some space, extra space like O of n. Quicksort is one of the most efficient sorting algorithm, and it is used oftenly by the people and some companies. Oftenly they are using the quicksort. Implementation of quicksort. Quicksort is a sorting algorithm based on divide and concurrent algorithm that picks an element as a pivot and partition of given arrays around the picked pivot by placing the pivot in its correct position in the sorted array. Here we have taken the example 10, 16, 8, 12 and 5. Let us using quicksort. Come, let us solve this problem. Let us consider a first element of array as a pivot element. Now 10 is a pivot element. Just compare pivot element with the next element. It's 16. 16 is more than 10. So that we need to compare 16 with the last element of array. That's 5. Here you can see 5 and 16 are swapped out. And then compare pivot element with the next element. It's 8. 8 is less than 10. So that keep it as it is. Then start comparing with the other terms. And the next to 8 term is 12. Just compare 12 with a pivot element. 12 is more than 10. So that we need to swap the number with the last digit, last item. But already we have swapped out. I and j, you can see that I and j are at the same position. So that we need to swap the element pivot with 12. 12 is more than 10. Now we need to take 12 comparison with last term of array. But in this case, we have already reached the last term, last element. I and j are at the same position, so that we can't swap the 10 with a 12. In this case, 12 is more than 10, but we can't able to swap 12 with a 16 because we already reached the last element. Then we need to increment j, but here j and I are the same position, so that we can't able to swap with a pivot element also, because 12 is more than 10, so that we need to transfer j towards the left. It's between like 8. Here you can see that j is transferred to 8. Then we need to swap the pivot element with 8, this element, because we have incremented j here. Here you can see that the swap is done here. 10 is swapped with 8. In this case, you can see that at the left side of a pivot element, it is less than pivot element, and the right side of a pivot element is more than pivot element. It is the rule of quicksort. And then we need to make a partitions between these two. Then we need to apply quicksort again for the first partition and the second partition. In this case, for our first partition, we need to consider pivot element as a first term, and for the second partition also we need to consider pivot element as a first term. And then we need to follow the same step with the quicksort technique, and we will get the result in the next slide. We need to follow the same steps. Here you can see that 8 is compared with 5. 8 is more than 5. There is no element to be compared, so that 8 is swapped with 4. I'm sorry, 5. Then you will get 5 and 8. And we already solved this pivot element. And sub pivot element, the partition element as some pivot element. This one we can't able to swap out these things because it is already sorted. But also we need to check the elements eligibility, or we need to check the rules. Then the result we got is 5, 8, 12, 10 and 16. Thank you guys. Thank you for watching my video. If you like this video, please like and subscribe the channel. Don't forget to click a bell icon to be updated guys. Thank you guys. Bye. See you.